So in this section, we have been talking about modern JavaScript development. So things like tooling and modules. But now let's finish the section by also talking about modern JavaScript programming itself. So basically about how to write modern and clean JavaScript code. And this lecture is actually mostly going to be a review lecture. So a lecture where I'm going to bring together all the clean and modern JavaScript techniques and practices that I've been showing you throughout the course. And so with this, you will then have all this information in one place. Then, in the next lecture, we will actually bring some of these topics to practice by fixing a bad coding example that does not follow these practices. But anyway, let's now get started. So, one of the most important things when you code is that you should write readable code, which basically means that you should write code so that others can understand it, and also so that you can understand it yourself in the future. Also, you should try to avoid writing too clever and maybe overcomplicated solutions that might make you feel really smart as a developer, but which also might make your code very confusing and unreadable. And so in many situations, it's best to simply write the most straightforward solutions. Another thing that's very important for readable code is to give functions and variables very descriptive names. So for variables, you should name them according to what they contain, and for functions, you should name them according to what they do. And so by doing this, you will make it really clear and obvious to everyone what each variable is and what each function does. Next, there are some more general rules that you should follow in order to write modern and clean code, which are to use the dry principle, so don't repeat yourself, which means that you should essentially refactor your code whenever you can. Also, you should not pollute the global namespace and instead encapsulate your data into functions or classes or modules. Also, you shouldn't use var for declaring variables, right? So I've mentioned this one many times in the course, and so by now you already know that you should always use const, and only if you want to change any variable, then use let, but never var. And finally, you should always use strong type checks. So always use the triple equals over the simple double equals, which do not perform type checks. Now, about writing functions, which is one of the most important things that we do as JavaScript developers, the main rule that we should follow by writing functions is that each function should usually only do one thing. All right? Now, many times, of course, we will want to break that rule, but in general, it's good to keep this rule in mind so that you always write like small functions which only do one thing, but do it really well. All right? Next, you shouldn't use more than 3 parameters in a function. And this actually goes in line with the previous guideline because, of course, if a function only does one thing, then probably it doesn't need so many parameters in the first place. Also, use default parameters in your functions whenever that's possible, and in general, return the same data type as you received. So, for example, if you receive 2 or 3 numbers as an input to a function, then probably you will want to return a number as well. So that then makes more sense for when you consume, so for when you use the function later. And again, this is a rule that you can of course break, but it's again good to keep this one in mind. Finally, you can and should use arrow functions whenever they make the code more readable, okay? And here, many people actually have different opinions. So some people started to use arrow functions everywhere, and some people don't like them at all because they think that they completely make code unreadable no matter when they're used. But personally, I like to kind of follow a middle ground. So I still use the more regular functions in many situations, but if arrow functions make the code more readable, then I will totally use arrow functions. And one great use case, in my opinion, is in the callback functions of array methods. And now after functions, our next topic is object-oriented programming. And in my opinion, in order to implement OOP in JavaScript, you should now use ES6 classes. And so that's also what I did after our OOP section, right? Now, when designing your classes, make sure that you encapsulate any data that shouldn't be accessible from the outside so that you don't mutate that data from outside the class. All right. Now, probably you will still need to at least manipulate some data that's in the class, but for that, you should then implement a public API, so basically a couple of methods that can then manipulate that data exactly as you want that to happen. And again, we talked about all of this already before. So this is really just a review of all these big topics that we have been handling throughout all of this course. Now, as you implement your methods in your classes, make sure that you implement chaining in all the methods where it actually makes sense, because this can make your methods way easier to use, not only for you, but maybe also for other developers on your team. So this is yet another great practice when you are writing your classes. Finally, one important thing to also mention here is that in regular objects, when you're writing methods, then please don't use the arrow functions there, because by doing that, you will not get access to the this keyword of that object. Remember? And so always avoid arrow functions, even if you're not even using the this keyword in a method, because simply by getting into the habit of avoiding arrow functions as methods in this situation, you will then not commit any mistakes ever. All right? Okay. Next up, let's talk about avoiding nested code. So writing nested code, which basically means writing code inside of blocks, inside of other blocks, is really, really bad for readable code. And so we should avoid nested code at all costs. And one great way of avoiding nested code is to use guard clauses, as we have been doing over the last couple of sections, right? So guard clauses basically simply means to use an early return in case some condition is not met. Also, you can use the ternary operator or even logical operators instead of an if statement, because the ternary operator, of course, does not create a new code block, while the if statement does. Now, if you really do need an if statement, then instead of an if-else statement, you should use multiple ifs instead, because again, this will make code a lot more readable than having to go through all these if and else if and else blocks. So that's also another modern practice that we start to see more and more in modern JavaScript code bases. Next, you should completely avoid any kind of loops. And with that, I mean any for loops. So the for and also the for off loops should be avoided if you want to avoid nested code. And so instead, you can use array methods like map, filter, and reduce. And finally, you should avoid callback-based asynchronous APIs whenever you can. And so that actually brings us to our next topic, which is asynchronous code. So for best readability, always consume promises using async await and not using the then and the catch methods, because these methods actually require callback functions, which will then introduce even more nested code. And so that's, again, something that we really want to avoid. All right? So these two go kind of together. So avoiding callback-based asynchronous APIs and instead opting for using promises and then consume these promises with async await. Now, something that's very important is that whenever you can, you should run promises in parallel using the promise.all combinator function. So when you have two promises that can run at the same time, so promises that do not depend on each other, then please run them in parallel to make the application a little bit faster for your users. And finally, always handle errors and promise rejections. So this is simply a best practice for clean code. Now, right. So these are the main best practices for writing modern and clean JavaScript code that I can think of. But now let's turn our attention to a completely different way of writing code. And so we're going to take a small detour here and talk about declarative code. So there are two fundamentally different ways of writing code in programming, which we also call paradigms. And these two paradigms are imperative code and declarative code. Now, whenever we write imperative code, we basically need to explain to the computer how to do a certain things. So basically, we need to explain every single step that the computer needs to follow in order to achieve a certain result. But this might sound a little bit abstract, so let's try a more real-world example. So let's say that we want someone to bake a cake for us. And so if we would do that in an imperative way, we would tell the person exactly the step-by-step recipe that they would have to follow in order to bake that cake. All right? So again, it is telling every single step that the person has to follow in order to achieve a result. And now bringing that back into code, here in this code example, we are trying to double the R array. And so this loop that I have here is a purely imperative way of writing that. So here we are telling the computer step by step to create an empty array, to create a counter that starts at 0, then to increase that counter until we reach the length of the original array, and then how exactly to store the new result in each new position of the array. So there's a lot of steps that we really give the computer here in order for us to achieve the result of doubling that R array. Okay, so that's imperative programming, but on the other hand, we also have declarative programming, where the programmer tells the computer only what to do. And so when we write declarative code, we simply describe the way that the computer should achieve a certain result. But the how it should do it, so basically the step-by-step instructions, they get abstracted away. So we do not care about them. And going back to our cake example here, the declarative way of instructing someone to bake the cake would be to simply describe that cake to the person, and then the person would have to come up with the step-by-step recipe on their own. So simply describing the task and the result that should be achieved is the declarative way of doing it. All right. And now coming back to the code example of duplicating the values in an array, this is how we do it in the declarative way. So we have our array, and then we simply tell JavaScript that it should map the values in the R array to a new array. And each of these values should be multiplied by 2. And so if you compare this code example with the one on the left, then you will really see that in this example, all we are doing is to describing the way that the computer should achieve the result that we are looking for. We are simply telling it what to do, which in this case is to simply map the original array onto a new array and doubling all the elements. But all these super detailed steps that we have on the left side, like creating an empty array and initializing a counter, all of these steps have been abstracted away because we don't really care about them. All right? And this is pretty important to understand because more and more, this is how modern JavaScript code is actually written. So the difference between imperative and declarative is not just some theoretical difference. So the declarative paradigm is actually a really big and popular programming paradigm, which has even given rise to a sub-paradigm called functional programming. And functional programming is basically a declarative paradigm which is based on the idea of writing software simply by combining multiple so-called pure functions while avoiding side effects and mutating data. And actually, functional programming and writing declarative code has now basically become the modern way of writing code in the JavaScript world. So you will see declarative and functional code everywhere. And in fact, we have even been using it all along, but without really knowing that this style was called declarative and functional. Alright, but let's quickly go back to the definition of functional programming and talk about what side effects and pure functions are. So, a side effect is basically simply a modification of any data that's outside of a function. So, for example, mutating any variable that is external to the function is causing a side effect. So basically any variable that is outside of the scope of the function. Alright? Now, data does not only refer to variables. So, for example, logging stuff to the console or also changing something in the DOM is also causing side effects. But don't worry too much about this for now, because we will talk a lot more about all this in a whole section on functional programming that is at the end of this course. Now, by the time I'm launching this course, that section might not be there yet, but after some month it will be there, and by then you should totally check that out. Alright? Now, next up, a pure function is a function without side effects. So basically a function that does not mutate any external variables and that does also not depend on any external variables. So basically, if we give the same inputs to a pure function, it will always return the same output. And again, that's because it does not depend on any external variables, and it also does not manipulate them. Okay? And again, we will talk more deeply about this in the functional programming with JavaScript section. But I'm telling you all this already at this point, so before that functional programming section, because this actually has implications on the way that we write our code. So even if you're not a functional programmer yet, you can still start to incorporate some functional programming techniques into your code. So, for example, you can try to avoid data mutations as often as possible. And of course, this will not always be possible, but it's also not really necessary. So these are mainly just suggestions, but which will still create more readable and overall better and cleaner code. So another thing that you can do is to always prefer built-in methods or functions that do not produce side effects over the ones that do. And this is really important for data transformations. So whenever you want to do that, you should use a method such as map, filter, and reduce. So this is the functional and modern way of doing data transformations, and many times this is actually the first contact that many people have with functional programming. So map, filter, and reduce are actually present in all functional programming languages, and they are very important to implement functional code and more declarative code in our code. And finally, you can also try to avoid side effects in the functions that you write yourself. And again, this is of course not always possible and also not always necessary. So we will never be able to avoid all side effects in applications because, of course, at some point, the application needs to do something. So we need to display something on the DOM or log something to the console or really create some side effect. Okay, but you can still try to think about this and to start incorporating side effects more into your own code. And why all of this is such a good idea, we will discuss at length again in the functional programming section. So this lecture here is really more about suggestions and things that you should start doing when you write your own code. All right. And now to finish, let's come back to declarative syntax, because functional programming is only a part of using and writing declarative code. So in order to write code that is more declarative, you should use array and object destructuring whenever that's possible. You should also use the spread operator, the ternary operator, and also template literals whenever that is possible. Because if you think about it, then all of these 4 ways of writing code actually makes the code more declarative. So these operators are more about telling the code what to do and not exactly the steps that it should take, right? And that's, again, true for all these 4 pieces of syntax. All right, but that's enough talk for one lecture, and so let's now put some of these guidelines that I gave you for clean and modern code in practice.